Unit 14 is called definite integrals. We've learned about integration, and integration means that we're finding the area under curves. And normally it's always the area between the x-axis and a curve. So lesson 14.1 is calculate definite integral from a graph. This will be level 1 and 2. They're pretty easy. It says the regions A, B, C, and D in the figure below are bounded by the graph of the function f, so all the curved lines, and the x-axis. They give us then the area of the region A is 8, B is 9, C is 12, and region D is 16. What is the value of this? Well, remember that this is the integrand sign, this little curved symbol, and it's going from x values of -4 to 7 of the function with respect to x. And so again, I just want to make clear that we're finding the area between the x-axis and the curve. So it's finding this area, or this area, or this area, and then this one. You could even find here this little triangular piece and this little triangular piece. If a area is below the x-axis, so like here, here, and here, it's going to be negative. So in region A, that's 8, but that's going to be a -8. B is 9, it'll stay positive. C is 12, and then D is 16, which again would be negative. But again, they want us to go from -4 to 7. So from here all the way to here. And so we're just going to simply add 9 plus 12 minus 16. That would be 21 minus 16 would be a net area of 5. Pretty simple. All right, number 2, this is a level 2. Function f is shown below. What is the value of the integral of -9 to 6 of the function? Write your answer in simplest form. So -9 would be here, to 6 would go to here. So we're trying to find the area of this triangular piece here. And this triangular piece here. This trapezoid down here, so we'll have to remember how to find the area of a trapezoid. And that would be it. And again, this area would be negative while these two are positive. So area of a triangle is 1/2 times base times height, because it's half of a rectangle. Area of a trapezoid shape is 1/2 times sum of the bases times height. We kind of talked about that with finding area with our Riemann sums. So here I would have a height, which would be this. A height has to be an altitude of a triangle. Sometimes they give you right triangles, sometimes they don't, but the height has to be making a 90 or right angle. So that's a height of 1, 2, 3, 4. And then this has a width of 7. So that first one would be 1/2 times 7 times 4, which would be 28. Half of 28 would be an area of 14. Okay, next one. This would be our height. That looks like 6. And then the base would be 1, 2, 3. So we would have 1/2 times 6 times 3, which is half of 18, which is 9. And then our trapezoid, this is a base, this is a base. So we'd have 1/2 times 1, 2, 3, 4, 5 plus 1, 2 times the height, which again, you could use any of it, but it's got to be making a right angle, and that looks like a height of 6. So 5 plus 2 is 7. We could go ahead and take 7 times 6 is 42. Half of 42 would be 21, but it would be negative. So we're adding the areas of 14 plus 9 minus 21, which would be 23 minus 21, which is an area of 2.